Hey, George.
Hi, Tavi. How are you doing?
I'm doing well. I'm doing well. We were having some technical issues here, but I think we'll be overcoming them. You are still a host, right, for this session?
I don't know if I am or not. Let me see if it looks like it's going to let me share my screen. So that's all I need.
That's exactly right. Well, thanks again for being willing to do this.
So not a problem. It's I'm enjoying this project, although it's been a real push to get this product complete. So,
We appreciate your efforts there. Absolutely.
yeah, one thing I didn't tell you is that this ended up being adjacent to a week that I spent in Colorado at Breckenridge skiing. So this time yesterday would have been 11. I would have just been finishing up skiing down Peak 10.
Oh, wow. Well, thanks again for doing this. This is even more important and really more appreciable your effort. You got good snow there?
Yeah, it was fantastic. Maybe the best week of skiing I've ever had.
Oh, wow. That's nice. Nice.
Incredibly good weather. We had good snow, and of course it's spring, so it's pretty warm.
That's great. That's great. We will wait a couple more minutes, and then we'll get started.
So we are connected through the panel to the Zoom call now.
Yeah, we are having someone giving the conference from outside.
They're giving the conference from outside?
Yeah.
So they're going to be sharing their content?
He's going to share his content.
Okay, so I will stop our content. That way they will be able to share their content.
Research team.
So you don't need to share any content.
Are you writing a
section? No. Okay. Dr. Yashimizu, can you hear us?
Yes, we're preparing an RC2.
Hello?
Actually, I'm involved in
I can hear you, but I'm getting a lot of feedback.
two RC2 ideas. So.
How about now? Is that better?
There we go.
Okay, so you can, I think that you can you try to share your screen as please, we'll see.
Sure. Hang on.
Yeah. Dr. Yashimizu, you can come here. Let me go and call him. He cannot hear me.
I will. I can hear you. I can hear from here.
Okay.
So content is here?
Voilà, we can see your contact now, yeah?
Yep.
Voilà.
And
Things are working, is that correct?
it looks like it's working on our end.
His voice is not clear, I think.
So,
Hello.
how are you?
Can you see the people in the room, or do you see me at the podium?
I see you at the podium right now.
All right, I'm going to change it. Let me know. Can you see the people in the room now?
I now see the room.
Great.
But you're very, very tiny.
Like just recording.
So are we
Should be all set then.
using that station or this
He's
one?
moving to this station.
Oh, you're going to be presenting as well?
I will be introducing the speaker.
Okay. You can either do it from there
I can
or
do it
over
from
here.
there.
You'll probably have a better pickup here. That green light there is actually a ceiling microphone, so you could sit there and project, but otherwise it's here.
Why don't we get started? You can hear us, George, still?
Yes.
Perfect, perfect. Welcome, everybody. This is Octavian Ioachimescu. This is Implementation Science for Innovation and Discovery series. I'm not going to do too many introductions today, but you have probably met already Professor George Easton from Emory University, and he has a fantastic talk that I'm not going to take away any time from. He will discuss with us a little bit of an implementation science project that he has created by using large language models in looking at the implementation science literature and what type of studies are out there, and if we can use this type of tool in our day-to-day life in implementation science practice or research. So I will stop here. Thank you very much, George, and the podium is yours.
All right. Well, thank you very much for inviting me. It's a pleasure to be back. So I guess I'm just going to go ahead and dive in with the motivation of what I'm doing here. And it was really motivated by the question, what is implementation science really? And so obviously there are written definitions of implementation science. I'm not going to go through that again, but there is, in many cases, practice oftentimes deviates substantially from these theoretical written definitions. And having done sort of a cursory look at a number of papers, I kind of felt like this was probably true for implementation science. And we'll see if that sort of plays out. But the basic idea was to see what implementation science actually is in practice by analyzing the implementation science literature, okay? And even if the definition that's written down of implementation science does in fact encompass what is going on, so there's a fairly good correspondence between the definition and what actually happens in practice, it's still interesting to know what areas are being emphasized. So how would one go about this in a traditional way? Well, you do some kind of systematic literature review or meta-analysis. And if this was done well, it would involve multiple skilled human raters who would read these papers carefully. It would also involve, before they really got into that, development of an instrument to extract that information from the paper. So those raters would basically be filling out a questionnaire about the paper. And then once those raters had analyzed and filled out the questions on the papers, there would be statistical analysis to try to understand the agreement between the raters, inter-rater reliability, and so on. If the raters were unable to correlate fairly well with each other, then you'd throw out the rating. So that's a very important part of that. And once you had analyzed the ratings and were fairly confident that the raters could do what you wanted them to, then the data that was extracted from those papers would be analyzed statistically. So that's what would be done traditionally. So about 18 months ago now, it's remarkably short time ago, ChatGPT was released, and it's a large language model, LLM, and I know everybody knows this, so I'm not going to spend a lot of time on this. But ChatGPT's ability to understand and respond to language really is very impressive. And I think if you don't agree with that already, you'll agree with that after I've shown you what I'm showing you today. The analysis of text, however, has been a part of machine learning for a long time. There are a lot of methods out there that can do things like document clustering. But even though there have been a lot of approaches in machine learning for analyzing language data, ChatGPT really does offer sort of new approaches and capabilities. And so the basic idea of what I'm doing is to apply AI and machine learning tools to the analysis of the implementation science literature to see what it really is in practice, okay? And that is what I've implemented here. Because of ChatGPT's impressive ability to understand language, and also to some extent because of the current hype, I'm not completely non-influenced by that. It's rather natural to sort of see how well ChatGPT does at extracting information from these public papers. And the idea here is that perhaps these large language models can really substitute for human raters in trying to understand a literature like the implementation science literature. So a lot of the tools that I'm developing here are not specific to implementation science, and I'm intending to apply them also to other literatures as well. Okay, so a disclaimer, this is very much a work in progress. What I'm showing you today is really a prototype. and partial analysis. And I think, you know, as I get into this, it'll be sort of obvious, you know, what needs to be done next. The other thing I wanted to say is this area of large language models is changing very rapidly. And what that means is that any approach that you sort of freeze and take is likely to be at least somewhat obsolete by the time you even have it implemented. Okay, so in this project, I've made certain decisions about how I'm going to do things, and they're fixed, and whether or not they're the absolute best thing to do right now is not clear. And in fact, they probably aren't, as I say, because things are just changing so quickly. At this point, I'm only using ChatGPT to analyze these papers. My plan is to also implement these methods using BARD, which has just changed its name to Gemini, as well as other large language models. There are at least 6 or 8 large language models that are out there that are in the public domain that are free to use. And so there is the opportunity to really use these models in the roles of the multiple raters that you would have if you had human beings doing this. Okay, if there are any questions as we go through this, please feel free to interrupt me, okay? I'm not very good at trying to monitor the chat. So if there are any questions or if I'm making assumptions about what everybody knows that aren't correct, please interrupt. The way I really think about these large language models is they are mimics, okay? They work by developing extremely complex models that are primarily based on neural nets that basically predict the next word in a document. If you don't know anything about these large language models, just think that what's going on here is that the next word is being predicted. In reality, they're actually predicting a token, and for the purpose of this talk, understanding the difference between words and tokens makes no difference at all. The large language models are trained on huge amounts of data, and in that process, they develop really a rather impressive understanding, and I put that in quotes because the reality is they don't understand anything, but an impressive understanding of the structure of language, okay? And that means a model in sort of an abstract sense. In the process, they also learn a vast amount of specific information, which I've called facts, because sometimes it's true and sometimes it isn't, but including definitions of words. So, you know, you can ask ChatGPT to define something like a cluster randomized controlled experiment, and it will give you a pretty good definition. And in fact, I often ask it for these definitions before I create the prompts that I use, because I want to make sure that I have a basis for thinking it can, in some sense, understand what I'm asking. So what large language models do is they provide responses to prompts. And so these are language models. So the prompts are generally a text-based, and there are limits to the amount of text that can be submitted, okay? And that turns out to actually matter, at least in what I'm doing. For some uses of ChatGPT and the other LLMs, you can immediately assess the quality of the output, okay? And I'm gonna make this point here, hopefully in a funny way. I'm going to, I guess I'm going to escape here and copy this prompt that says, write a funny poem about the frustrations of writing grant proposals in the field of implementation science and healthcare. Okay, so I'm gonna submit that to ChatGPT here in real time. Hopefully you can see it. And it will write a poem, and it writes a different one every time because there's a randomization factor. And I'm not going to read the whole poem here, but let's just get a little sense of it. It says, in the realm of health where minds conspire lies a land of frustration where writers tire. Grant proposals, oh grant proposals, the bane we bear. In implementation science, a tangled affair. One more stanza and then I'll stop. With pen in hand and coffee by the pot, we embark on a journey, but alas, we're caught. For every hypothesis and well-crafted plan, there's a reviewer's critique like a frying pan. Okay, So, so hopefully you've enjoyed that. But my point here is that I've asked ChatGPT to do something that's generative, but I can immediately judge its quality. Okay, and that's the real point that I want to make here, is that in some cases when you ask this AI to do something, you can tell if it's done a good job or if it's at least met your purposes. But in many other cases, you can't. And in fact, in what I'm doing here, I'm going to be asking ChatGPT to extract information from research papers, and I can't tell if it's done a good job just by looking at the output. So in that case, you really must statistically assess the quality of the output by validating the output against known correct answers via an independent validation sample. And this is exactly what is normally done in machine learning. You use one sample, a training sample, to create the models. You use a validation sample to actually pick the best model, but basically to make sure that it's working. And the problem with these large language models is it's extraordinarily tempting not to do this, and I'll say why in just a second. But the key thing here is if you can't immediately judge the quality of the answer that you're getting, you've got to treat this really in the same way that you treat any other machine learning problem. In these large language models, each prompt that you submit is in some ways like a new machine learning model. Okay, and I think that'll become clear as I get into this as well. And these large language models are tricky because, in a sense, what they have been developed to do is to sound good. Okay, and by that I mean they sound like they know what they know what they're talking about, and so they're kind of deceptive in that sense. And I just wanted to, really lay out that there are cases where you can immediately use the output because you can judge whether it's any good, and other cases, like I'm using it, where you can't. LLMs are only as good as the data used to train them. This is potentially a big problem. And also, there are no guarantees that the models will not change. And this, if you're trying to use these things to do research, this is a huge problem. If you haven't validated the model for your use, then it may be subject to biases that are built into the data or built into the, into the owners of the algorithm that are trying to achieve something. But it's also troubling that these things are changing all the time, and you may develop your model and validate it, and then it potentially changes. And this is a problem with all use of software as a service in general. Okay, I wanted to say something very quickly here about unstructured data. The basic idea of unstructured data, which is what the text of a research paper is that it does not come in a format that can be put directly into a row vector of variables that might be found in a data frame used in regression. Okay, so you can't take unstructured data and just plug it in as a row in a regression. That's the way I want you to think about this. Unstructured data, unlike your typical set of variables in a regression model, say, usually has variable length, and the presence or absence of specific information is variable. So sometimes it's there, sometimes it isn't. And the location of that information in the data is also variable, and the format may change. Language data is usually unstructured, so text documents such as emails or product reviews are good examples of unstructured data. So are research papers. The way that you handle unstructured data, essentially always, is that you take that unstructured item and you compute a set of statistics from it. And once you compute that set of statistics, that set is now structured and it can be put into a row of a data frame. So that's basically how unstructured data is handled in machine learning in general. So some very simple examples might be the average word length, or whether a piece of text has a positive or negative sentiment. Those would be statistics that would be computed. But the key thing that I want everyone to know is that the way you handle unstructured data is to take that data and compute a set of statistics from it. Okay, again, if there are questions, please interrupt me, okay? So in this research, I'm using ChatGPT to extract the structured information from the research papers. And so as a very simple example of what I'm doing here, I might want to know if the paper describes an experiment. And if it does describe an experiment, what is the sample size? Okay, so that's the kind of thing that I'm asking ChatGPT to extract from the papers. Most of the variables that I'm extracting from these papers are categorical variables. An example of that is the area of healthcare that's addressed in the paper. So one area that, for example, would be radiology. And so these categorical variables are often called factors as well. And so I'm using ChatGPT to extract the values of factors. Because the large language models do have some real sense of the structure of language, what I'm asking ChatGPT to do, it should be rather well suited to do. Okay, and the extent to which this actually ends up being true, this hypothesis that I essentially have that these large language models are particularly good at extracting data from language. The extent to which that's true is something that in a sense I'm finding out, and the results there are a little bit mixed, but we'll see that. Okay, I need to explain prompts, and I'm going to use this slide for that purpose. But I need to talk about what you would do traditionally in developing a machine learning algorithm. So to develop a machine learning algorithm, you would need a large data set that's specific to that area of application. So for example, if I wanted to train a model to look at text data like a research paper and determine whether or not there was an experiment in there, I would typically have to assemble a very large set of these papers and hand code them as having an experiment in there or not, and then build a model to predict that. So you would have this large data set. You would then use one or more specific method or algorithm, neural nets would be an example, to develop the model for the data. Assembling this large data set, cleaning it, and so on is typically very time consuming and expensive. And building and testing the models can also be rather resource intensive, although I will tell you that in machine learning, the development of the algorithms is usually less work than the assembling of the correct data. Once you build this model, it's specific to the domain where you trained it. And it's not easily transferable to other domains. You can get around this to some extent because if you have another model that's been built for something that's similar, then maybe you can start with that model and you can train it on your specific data set, and you can get a good result with a smaller data set. So in machine learning for quite some time, people have tried to speed the development of these models by starting with a model that already exists and essentially training it sort of away from that application towards their own with a much smaller data set, but it's still very time consuming and expensive. So the focus of this slide is on the game-changing aspects of the large language models, at least the way I want you to think about it in terms of applying it here. ChatGPT and other LLMs have been pre-trained on such a vast amount of language data that they have general knowledge in the sense that they work quite well in many specific domains. So the way I'm thinking about this right now is that the large language model, in a sense, is like having a pre-trained model that works pretty well for broad sets of areas of application. So it's like having many domain-specific models that are already trained and work fairly well. And so this is a huge time saver. ChatGPT and the other large language models can be tuned to your own area of application using a smaller data set in exactly the same way that machine learning models have been trained in the past. And you can do this with ChatGPT. And again, if you do that, the hope is that you'll be able to train the model to work very well in your application with a much smaller set of data. But it turns out that there is a much simpler and easier way that often works. So what people found as they've been playing with this stuff is that you can oftentimes make the large language model work much better in your domain of application if instead of assembling a data set and training it on that, what you do is you modify the question. In other words, in many cases, you can make the model work rather well in your own area of application by tweaking the way you were prompting it. The specific question that you ask a large language model like ChatGPT is usually contained in a context. Okay, and it turns out that that context can be fairly important. So I want you to think about the prompt as having a question and a context. And so by experimenting with and changing the prompt, you may be able to make the model work much better for your specific domain of application. So you may change the question you're asking, ask it in a different way. You may try to change the context around that question. And this is what is now called prompt engineering. Prompt engineering is about trying to change the prompt to make it work in your particular application. Practical experience has uncovered some strategies for developing these prompts that seem to work quite broadly. And I'm going to talk a little bit about that. Well, I guess I'm going to come back to that and tell you how I've developed the prompts for this particular case. But first, I'm going to tell you what my sample is. My intent is to get essentially all of the papers that are published that address implementation science. And having searched the literature, I think there are about 6,000 of them. Roughly 2,000 of them, 2,070 were published in the journal Implementation Science. And so and I think there are another 3,000 to 6,000 papers out there. And the reason I think that is I've also looked at Science Direct and Web and Science and so on. But I'm going to focus in this talk and what I've done so far only on the 2,070 papers that have been published in the journal Implementation Science. The journal began on February 22nd of 2006, and the sample that I have stopped as of June 9th of 2023. So another thing on my to-do list is to update this sample, but that's what we're working with now, papers between 2006 and June of last year. I had to make a variety of decisions, and I decided that the standard way, and I think everybody will agree with this, the standard way that research papers are really published and transmitted is a PDF file. An alternative, many journals do publish an HTML version of the paper, but what I am using in this research is the set of 2,070 PDF files that correspond to the papers published in the Implementation Science Journal. And I've already said this, but I'm expecting to end up with about 6,000 papers when I am including papers from other journals and other sources. So the basic strategy that I've implemented here is as follows. The first thing is that I remove the text from the PDF files by section of the paper. So so research papers are unstructured data, but they do typically have a structure, sort of a macro level structure around it, and those are the sections. So a typical research paper would have an abstract, an introduction, a method section, a results section, a discussion, or conclusion, or maybe both. Okay, and so I want to be able to exploit the structure that's in the papers because I would expect certain kinds of things that I care about to be described in certain sections. So for example, if an experiment is conducted, I would expect it to be described in the method section. So what I did is I pulled the text out of these papers by section from the PDF files. Now it turns out that there are quite a number of technical problems around this, and we don't have a lot of time, so I'm not going to get into those specifically. PDF files are not organized in a good way for pulling this information out. For example, they have 4 or 5 different kinds of objects, and the objects are sitting there on the page, and they all have a location and dimensions and so on, but they're not necessarily in the same order that you would read them. So there's quite a few challenges about getting the text out, but assume that I've done that reasonably well. And what I've done is I've pulled out the text that corresponds to each section of the paper. The next step is to develop prompts for ChatGPT that extract the desired information from the text. And I'm basically using 5 prompts, and I'll be telling you about those in just a second. Once I have the prompts, so for example, one of the prompts that I want to know is what area of healthcare is being addressed in the paper. Once the prompt is developed, then I need to assemble the text to give ChatGPT to make the decision as to what area of healthcare is being addressed. Is this a project in cardiology, for example? And again, because of the limits of the tokens, and also because I want to use the information in the structure of the paper, I'm going to assemble text for that question by pulling the text from the relevant sections of the paper. And so for each question that I'm asking, or category of questions that I'm asking ChatGPT to pull this information out, I have a prompt, and that prompt is going to be submitted along with the relevant text for each paper in my sample. Okay, so if I want to know whether there's an experiment and what the sample size is, I write a prompt for that, and then that prompt will be submitted 2,070 times with the text that is pulled from the corresponding paper, because there are 2,070 papers. ChatGPT then pulls the data that I want out of it, and then that data is then going to be analyzed in sort of a traditional way, the way you would analyze the data from a similar review done by human raters.
George, can you hear us when we talk in the room?
Yes, I can.
What do you mean by assemble the appropriate text? Do you mean assemble all the introductions from 2070 papers, then all the methods from 2070 papers and so forth? Or what do you mean by assemble the appropriate text?
Great question. What I mean is that if I want to know whether an experiment was conducted, the section of the paper that is most likely to tell me that is the method section. Okay, and I usually can't submit and would not want to submit the entire paper to ChatGPT, because it's very likely to exceed its limits in terms of tokens. Okay, and so what I'm going to do is just pull out the pieces that are most likely to answer the question.
From one paper at a time? From one paper at a time?
Correct.
Thank you.
Correct. And I'm going to show you in detail what these prompts look like in just a moment. Okay, and so ask me again if it isn't clear after we sort of look at this. All right. So I'm using ChatGPT 3.5 Turbo. It's not quite the latest version, but it has a better response time and so on. It has a limit of 16,000 tokens roughly, and that means about 27 pages of text. This limit applies to both the prompt you submit and also the response. Okay, the response is limited to about 4,000 tokens, and that's about 6 pages. So what I give it and what it gives me back, which might be 6 pages, can't exceed about 27 pages. Okay, so I'm going to talk about the prompt structure here before I actually show you some prompts that I'm using. And the prompt structure I'm using has, I think, 5 parts. The first part is that I want to indicate to ChatGPT what kind of persona it should be adopting. And so when I prompt it, and each prompt incidentally is independent. It's not influenced by the previous prompt that I am giving it. Okay, in the way I've designed it. But the context that I give it is that I say, you are a researcher working in the area of implementation science in healthcare. Okay, and for example, before I wrote this prompt, I made sure that it had some idea of what implementation science was. Okay, by asking it, to define it. All right, so that's the first thing. I give it a persona. The next thing I do is I describe what text it's going to be getting. So an example would be of describing what it's getting is as follows. As a research paper in the field of implementation science, the paper will focus on implementation into practice of a recent healthcare innovation or on improving an existing process. As such, it will focus on making one or more changes to the processes, systems, or organizational structure of a healthcare organization. Determine what types of personnel or roles are directly affected by these changes. Okay, so I've just described what it's going to be analyzing, and I've actually asked a question as well. Okay. The next part is I almost always provide examples of the kind of answers that I want. Okay, and this is a well-known way of improving its ability to respond. And in many cases, people only give a few examples. And when they give a few examples, it's called a few shot prompt. And so what I'm using here is really a long shot prompt. Okay, and so for example, if I'm asking it to tell me the roles that are affected by whatever's going on in the paper, I'm going to give it examples of a list of those roles. So I've pulled out just the top part of the examples from one of my prompts. And so the role might be a medical doctor, physician, doctor of osteopathy, a registered nurse, a nurse practitioner, a physician assistant, and so on. Okay, so step 3 is to provide it examples. Step 4 is to tell it what I want as the output. Okay, so as an example here, the prompt that I'm working with is the idea here is the paper is talking about some kind of change, either an innovation or a process improvement. And I want to know in these papers who is affected by that change. Okay, and so I refer to the essentially who is affected as the roles. So in this case, the prompt says, return your response formatted as JSON. JSON I'll tell you about in just a second, the bottom of the slide. Using 3 keys, role 1, role 2, and role 3. Describe each role or type of personnel in no more than 4 words. It is not necessary for your response to include all 3 roles or any roles at all. If any role is unused, return NA. Okay, so it's now going to return JSON with 3 keys, role 1, role 2, and role 3, and a 4-word description of what that role is. And then the last part of these prompts is the text to be analyzed, which will be submitted between delimiters so that there's no ambiguity as to what the text is. And following what other people have done, I typically use 3 backticks as the delimiters. Okay, what is JSON? JSON stands for JavaScript Object Notation. It's a standard, simple text-based format for transmitting data objects between programs or over the internet. In this use, I'm going to use it. I always ask ChatGPT to return the response as a JSON object. And I do that because ChatGPT seems to understand this format very, very well. It performs well in terms of returning the data in that way. And my programming is written in Python, and Python has utilities to translate this JSON structure into objects. So I'm going to now show you some prompts. So let me just put this down. I have here on my screen, what you're looking at now is a program development environment for Python called Spider. That really doesn't matter, but I'm just telling you what you're looking at. And here I have the ChatGPT prompts. And let's just look at this prompt for asking ChatGPT to pull from the paper what the research methods are. Okay, and so what I've said here is okay, well, actually, this is one of my early prompts, so it doesn't have all 5 parts in it. Let me actually move down to another one. Okay, so here is the actual prompt for who is affected. So you'll notice up here, it says that messages, role. You don't need to worry too much about this, but this is where I say you are a researcher working in the area of implementation science in healthcare. And the prompt begins here, and I say, you will be given text taken from a research paper. Okay, I'm repeating what I did in the slides here. The text will be delimited by triple backticks below. Okay, the text consists of several sections from the paper concatenated together, such as the abstract, introduction, and methods. So what I'm doing here is basically giving it the abstract, the introduction, the method section only, and I'm eliminating the results and the discussion section. The next paragraph is where I give it a little bit more context and then ask the question. Okay, so as a research paper in the field of implementation science, the paper will focus on implementation to practice, so forth, so on. And then at the end, it says, determine what types of personnel roles are directly affected by these changes. Now, to make sure, in a sense, that it understands what that means, I give it the examples. So examples of roles or types of personnel in healthcare that might be affected by such changes are, and this list is not that short. And then I go on to tell it that these are examples, and there may be other appropriate roles. Okay, and that it's also possible that the paper is not discussing any roles at all. In other words, I don't want it to force a choice on the role if that's not appropriate. I ask it to identify up to 3 roles and then return the response formatted. Okay, so one of the things that may surprise you if you haven't worked with this stuff is how big a prompt can be. You know, a prompt is not necessarily 1 or 2 sentences. And the prompt to be effective can do much more than just ask the specific question. All right. So here's another example. In this case, I want to know what area of healthcare is being affected by whatever is happening in the paper. So in general, I'm thinking that the paper is involved in implementing either an innovation or a process improvement, and so I want to know what area of healthcare. So same sort of thing here. I give it the context, then I tell it what it's going to be getting, I ask the question, what area of healthcare is the focus of the paper? I give it examples. Okay, I then tell it that these are examples only, that there may be other areas that are appropriate. And I ask it, in this case, to return up to 2 areas of healthcare in order of importance as JSON, and those are going to be keyed as area 1 and area 2. Okay, any questions about that? All right. All right, okay, I'll keep going here. Okay, so let me go back to the slides. So the 6 prompts that I'm using basically are, at this point, are focused on the following issues. The first prompt basically pulls information from the article that's at the front of the paper, and this is such things as the title, the authors, the date of the article, the type of article, and so on. The next prompt that I use basically wants to answer the question, does the paper focus on implementing an innovation, or is it focusing on a process improvement? Okay, so that's the second category of prompt. The third category of prompt is the research method. So I'm asking ChatGPT to return the 3 most important research methods used in the paper. The fourth prompt is the area of healthcare. So I'm going to ask ChatGPT to indicate the 2 most important areas of healthcare that are the focus of the paper. The next prompt is the one that we were using as an example, and that is tell me who's affected by whatever's being implemented. So the role of the person affected. And then the last one that I've implemented to some extent at this point is information about any experiment that is conducted. So I'm going to ask ChatGPT whether the paper includes an experiment. If it does, I want information about the experiment, such as the sample size and the unit of analysis. Okay, so now I've prompted myself to show some actual code running. And so I'm going to go back to my code window here, and I'm going to go to Analyze Papers, and let me just run this, and you'll get some idea of what is coming out of it. So let's see, Shift F9, and then this will run for a while. So let me make the window big enough that you might actually be able to see it. And if I come down to the end here, what you're seeing is the answers to the questions for each paper. So, so let me just see here. This is paper 2 that's just beginning to show up. And here's the front matter that's pulling it off, all these brackets and so on, and the keys. So for example, method 1 is a randomized experiment. I'm going to stop this in a second so that we can actually look at it a little bit. But what's happening is it is for each paper, okay, we've done about 6 of them so far. It is, I think in this file, executing 3 different prompts. And each one of those prompts has the structure that I've talked about, and it's going to ChatGPT with that prompt and the sections of the paper that are relevant to that, and then pulling out the information. So I'm going to kill this so we can look at it a little bit closer. Hopefully you can see it well enough. Let's just back up here. Doesn't really matter where. This is the 7th paper. It's numbered 6 here, but in Python everything counts from 0. This is the name of the PDF file. It is a research article. Its title is Explaining Variation in GP Referral Rates for X-rays for Back Pain. Its authors are Rachel Baker, Jan, I can't pronounce the name, and Singa Bond. Okay, and this papers are being pulled into the program in order. So this is a very early paper. The primary research method is interviews. Okay, and in addition, ChatGPT thought it did qualitative analysis, which would certainly correspond to interviews, and then something constant comparison. I don't know what it means by that. I'm going to skip over this one for now. What's the area of healthcare? It's primary care and radiology. Okay, and then we go to the next article. Well, let's just quickly look at that. In this article, the primary research method is a systematic review. Okay, this format here. Where did I do the sections? Okay, these curly brackets and this format of a key followed by a colon and then whatever the answer is to that question, that's the JSON. So you're sort of seeing the JSON go by. Okay, any questions about that? All right. Okay, there's some code. I've done that. For whatever reason, I like to see the code running myself, so I thought I would show it to you. All right. So here's some preliminary results. Again, we're looking at this sample of roughly 2,000 papers from implementation science. Implementation science actually does categorize these papers. Well, kind of categorizes. There's a word at the top that's or a couple of words that says what type of paper it is, and I've shown you the percentage of papers here by type. So the largest percentage of papers at about 45% here are research articles. Another very large category at about 25% are study protocols. Okay, the next biggest category are systematic reviews, and then there's a whole bunch of sort of, I'll call them junk categories. The people who write in those categories may not feel that they're junk, but they're debate, meeting abstracts, papers about methodology, and so on. So that gives you some idea of how those papers break out. I am using the sections in the articles. I pull the text out by section, and then I use the sections that I think are most relevant to what I'm asking in the prompts. And this graph is showing you the frequency that the papers have various sections. So roughly more than about 90% of the papers have a reference section. This is not too surprising. In some sense, you know, doing this is checking that you know, things make sense. Almost every paper has an abstract, repeating interest. This is an unimportant section for the meaning of the paper, but it's apparently required. It has author contributions. Then we get back into what's important in the paper. More than about 85% of the papers have a method section. They have author information, again, which isn't that important to what we're trying to do, but they have a discussion section, a background section, a results section, and so on. So this is showing you the frequency that these papers contain these various sections. And certainly, you know, I came into this with the idea that a standard research paper has an abstract, an introduction, a method section, a results section, a discussion section, and a brief conclusion, and maybe future work. In the graphs that I'm showing you now, I've restricted the analysis to only research articles. Okay, and the sections that are found in the research articles are not that different from the population overall. So I'm not going to go into this slide in any detail. This graph is, I think, quite interesting in terms of understanding what implementation science currently is. This is looking at the research articles. There are 845 of those out of the 2,000. And the most common research methodology used, as pulled out by ChatGPT, are interviews, followed by surveys. The next most common category are cluster randomized controlled trials. Then next is quantitative analysis. I can probably zoom in on this. Okay. Sorry, I rather than zooming it, it changed the slide. qualitative analysis, systematic reviews. There are a lot of review articles, case studies, and so on. So the interesting thing here, and it would be interesting to compare this to other sort of fields, but certainly implementation science currently, if this is a representative sample, is very much using qualitative methods. I kind of looked at this and thought, you know, somebody should develop a maturity model for research in various fields. But I imagine that over time, the percentage of papers that are using some kind of randomized experiment really should sort of go up. Any questions about that?
Just a curious observation. If you go back a couple of slides.
Okay.
Yeah. So I was looking at the other side of the spectrum where only less than 1% is discussing limitations of their research.
Oh, yeah.
What was, which I thought was kind of interesting.
Yeah.
Well, on the next slide where you have analyzed just the research studies, where is limitations in that?
Okay, so I think this is the slide that you're referring to. So I want to be clear, in the slide that you're referring to here where it says limitations way down here.
Yeah.
That means that there is a section called limitations.
Uh-huh.
Okay. So it's possible that limitations are discussed in a discussion section. Now, if I go here to the research methods, this is data that is pulled from the method section of the paper. Okay, and I think I used the introduction and the abstract as well. So I did not provide ChatGPT with the end part of the paper where limitations would be discussed.
Okay.
Okay, because I wanted to pull out the research method.
Okay.
Now, this is very surprising how small percentages these are, right? Of different categories, which begs the question.
Oh yeah.
Probably a lot of papers would have a combination of these, right?
No, thanks for pointing this out. I've divided by the wrong end here. Okay, I guarantee you.
Okay.
Okay. So I'm sorry about that. I went through earlier today. I had counts of everything earlier, and I thought I needed to convert them to percentages, and I obviously screwed this one up. Okay, but the visual, of course, is not affected by that. Okay, and let me just see if I have research. Okay, all right. So this, yeah, I thank you for pointing that out. This is the scale on the is clearly wrong. Okay, I could probably fix it in a second or two, but I won't try to do that. The next slide shows the areas of healthcare that are discussed in these papers. So, for example, at about 13%, the papers are discussing primary care. Public health is the next major category. And then this was surprising to me. There's a huge amount of much more than I thought would be there that is somehow related to mental health. So psychology, psychiatry, and things like that. The next category is cardiology, and then oncology, and then geriatrics, and then again, you know, ChatGPT is doing this, and I've not done the validation yet with the humans that we need to do, but it's also included here implementation science as an area where implementation science is having an impact. I almost decided to pull that bar out of there, but I thought I would just show you what it's doing. Then it's obstetrics, pediatrics, and so on, neurology, and it tails off. Okay. As is typical in this kind of data, almost everything follows a Pareto distribution. So I think this is interesting in that Well, I don't know. I mean, did you all find this interesting?
Yeah, absolutely. The mental health part may be related to what Eve Rogers used to say, which was there were a number of groups that became very dominant in the field of diffusion of innovation back then and now implementation science. And these groups tend to be creating these research traditions, how they called he called them. And there are a lot of them that come from psychology and psychiatry in the early days of implementation science. So I wonder if that's not the reason why we see so high that field there.
Yeah. Well, you know, as I say, this is prototype analysis, but it'll also be interesting to see how this mix changes over time, right? And it might.
Yep.
You know,
Yep.
This is just the whole set.
The other comment I was going to
I-
make was related to you're almost doing bootstrapping of an article by just looking at the methods. And context, both internal and external, are so important in implementation science. I wonder what would be the output if you compare the output of the discussion versus the output of the methods, and to what extent you may identify additional roles, for example, like stakeholders or methodologies used by comparison.
Yeah, that's a great point. Now, for this particular slide, I provided it the abstract, the introduction, and the method section, with the idea that with those three sections, it ought to be able to tell what area is being impacted. But I did not provide it with the discussion, the results, or the discussion section, and it could be different. You know, the way I looked at this is you know, I think there are four main things that kill you. You know, one of them is heart disease, so that's up there pretty high. Okay, the next one is cancer, so oncology is up there pretty high. Okay, the third one is neurodegenerative diseases, so neurology is down here a little bit, but it's not way down in the tail. And then the last one would be metabolic related diseases, and endocrinology is maybe not as high as it should be. So as a complete amateur in this is kind of how I looked at it. Okay. All right. Now the very last thing here, and then I'll take questions, and I can show you more of the code and things like that. But what about experiments? Well, there were, and again, I'm only looking at the papers that are flagged as research papers. So there were 865 research papers, and the first question here is, did it contain an experiment? And so 683 had an experiment and 182 didn't. So that's about 80% have an experiment. Now, of the 80% that have an experiment, how many of them had a randomized experiment? Okay, there's a little bit of fall off in the number here. I haven't drilled down on that, but again, this is a preliminary prototype analysis. Of the ones that had an experiment, about a third of them had a randomized experiment and 2/3 of them didn't. Okay, and then of the ones that had a randomized experiment, how many of those were using cluster randomization? And it turns out that about 2/3 of them were using some kind of cluster randomization, and 1/3 were using randomization of the unit of analysis. And so I have another slide here. I don't know if you all can see it. Let's see. There is a way for me to zoom in. Let's try zooming in. Yeah, let me try to make that big enough. Okay, so down the left column are units of analysis, and down the right column, because there's such an emphasis on cluster randomization, I've called it the unit of randomization. But let's look at unit analysis here. So primary care physicians, dietitians' belief. Again, this is what ChatGPT is deciding. Dietitians' beliefs regarding SDM behaviors, implementers, practices and healthcare professionals, patients, health professionals in Parkinson's network, recommendations, and so on. So these are all mostly sort of person level things, like, for example, nursing staff in a surgical unit. Some of them are not QI teams. Now, if we go down the units of randomization, general practices, not sure why I have that twice, community health teams, communities, departments, clinics, these are all sort of bigger organizational units. So ChatGPT is kind of getting it right here. So, here's a classic cluster, nursing home or primary care practices. Okay. And, okay, so in everything that I have done so far, which is probably to run these prompts through this data set, I probably at least 25 or 30 times by now. Okay, the cost of using ChatGPT has only been $160. So when I started this, I really had no idea of how much money I would be burning in doing this, but it turned out to be absolutely negligible. Okay, so I think I've given you the structure of what I've been doing. I've got, as I say, everything that I've been doing here is right here in front of me. So I'll let you ask me questions about any of this. And we can also talk about future directions as well. And actually, I would love input as to the kind of information you would like out of these papers. As I say, this is a prototype. I've got, think of what I've done here as a rapid prototype.
Wonderful. Thank you so much for a great talk. I have a few questions and comments, but I'll try to make sure I'm not monopolizing the discussion section. Can you talk a little bit about, is there any risk of overfitting in large language models, the same as it was in early days of neural networks?
Okay, so my immediate response, if you ask me if there's risk of overfitting, is to say yes, absolutely. Okay, but now let's think about this in this context. There's absolutely a huge issue that still has to be resolved, which is determining the accuracy of its ability to identify and pull out the information. Okay, and I didn't really talk about this, but ChatGPT seems to be having a very difficult time deciding if something is an innovation or process improvement. Okay, and I think that's an important issue because my sense is, from discussion with you, Tavi, and others, is that what the NIH would like to do is really drive innovation into practice. And I have the sense, and I don't have the data for this yet, but the sense that much of this is process improvement, not innovation. Okay, but ChatGPT, as I've been looking at things, tends to label a lot of process improvement as innovation. So to answer your question, the usual machine learning structure of having a training sample and then doing validation absolutely has to be done to assess how accurate it is. Now, you specifically asked me about overfitting. And so overfitting happens when you're making predictions or if you're doing categorical, making decisions that in some sense chase the random variation in the data.
Or the bias of the data set you're analyzing, right? Because if you're taking, let's say, a different implementation science journal that maybe doesn't have the same structure of articles, but limitations, maybe it's a mandatory section. I'm just giving an example. Maybe the percent of discussion about limitations would be higher because of that. So all of a sudden you have
Yeah.
a structural bias that will change the way the data will look, right?
Right. Well, there's no question that having used only one journal, I'm biased. Okay. And so certainly, as I look at other journals, it'll be interesting to compare and see how things look. But I guess I normally think about machine learning as developing an algorithm that either makes a prediction or makes a decision. Here at this point, in a way, I'm doing descriptive statistics based on data that's pulled out of the papers by these algorithms, and I'm not feeling that overfitting is likely to be a problem. What's likely to be a problem is that ChatGPT just doesn't understand, and the data that I'm getting is garbage. Okay. So I guess that's the way I'll answer your question when I finally get back to it. We definitely need the structure. I have 100 papers that I'm using in some sense to work things out. So that's my training sample. I need to get human raters to rate another sample so that we can compare it. And the other thing is I need other large language models to see if BARD and ChatGPT agree.
Right. Well, I have another question, but Alex has his hand up.
Yeah.
So
Alex.
Yeah. Hello. Yeah. Fascinating and talking ingenious approach, and yeah, I can see it. If it works reliably, even at a certain percentage, it is a huge speed up in reduction in human effort for doing this kind of work. In terms of validating it or being able to validate this efficiently, are there prompts that exist that would successfully pull out key sentences or other pieces of text on which the decision is being made?
Yes, this is a great question. And let me answer it this way. The answer is yes. I'll interpret your question a little bit more broadly than you stated it. There are multiple algorithms that exist for pulling keywords out of papers. Okay, ChatGPT is also supposed to be fairly good at that, although I've not experimented with that yet. So it would be very possible to take the large language models like ChatGPT and give it a section of text like methods, and then say pull out the keywords and then analyze the keywords across the entire set of papers. Okay, and in fact, if I did that, I could make those word cloud graphics, right? And then there's not only the large language models, but there's about 4 or 5 other algorithms for doing that are non-large language model based. So doing that and comparing those, I think, would be quite interesting. Okay, and I'm not sure if I answer your question. Ask me your question again. Let me make sure I actually addressed it.
No, I can. Yes, I can see that as another approach for comparison. I was more specifically when you're getting. I mean, again, it's a clever trick in a sense that the model understands JSON well enough to give you structured output in what's essentially a generative conversational format. Yeah. But when it says, is it innovation or process improvement? I wonder if it can actually tell you if there's anything to which it's giving specific weight in making that determination.
So
that someone reviewing its output could do so faster than having to read the entire paper, or even just, or it's already doing an abstraction process. Can it provide some more? And it's a way of providing increased sort of focus on particular areas of the document. Yeah. I don't know.
That's a great. I mean, you've had a great idea there. these large language models are frequently used to summarize things. And you get on Amazon now and you're looking at a product and there'll be an AI generated summary of the reviews. Okay, they're able to do that because reviews are not long. So they can, I don't know how they do it if they give it all the reviews, because that's likely to exceed the token limit. Okay, or if they just do a random sample of the reviews or how they do it. But you've got this token limit that's a problem. Okay, but certainly if you wanted to speed up the reading of papers, you could ask the AI to write a summary of each section of the paper and specify the number of words. So write me 4-sentence, summary of the introduction. And I can see that actually as a product. You take these papers and boil them down to a short summary of each piece. I thought about this because I've handled the token limit by giving the large language model subsets of the papers based on the natural sections. And I don't think that's a bad idea, okay? But there are other ones as well. Another thing that you could do is have ChatGPT summarize each section and then give the summary of every section all in the prompt at once. So that rather than having the whole paper, what it has is a generated summary of each section of the paper. So,
Then we'll have to read all of that.
right.
Although I mean, one last comment to that, and then I'll let maybe Andrew or someone else take a turn. Of course, using it once you start feeding this model like output of itself, you're greatly potentially increasing the risk of bias or sort of self-deception in a way, because this is a generative mimicking process, as you said. It's not really understanding.
Yeah. Well, I would agree with that. I would say that at this point in the development of the technology, I would not trust anything like this until it had been statistically validated against known answers. And in this case, known answers has to be the result of human raters rating the papers. But what I've again, I'll just say what I've shown you is a rapid prototype. I wouldn't trust it yet, and I wouldn't trust what I'm doing until I've been able to get a random sample of the papers coded by humans.
You could probably, your next step could be to look at some of the meta-analysis that have been published and run the same query using ChatGPT and see if the results vary, because those meta-analysis are manually done. Sometimes hundreds of papers in one analysis.
Yes, that's a very good suggestion. I had thought I've done a review like this myself in my own research about 8 or 9 years ago. I was thinking about using that and seeing if it corresponded. But I think it would be better to compare it with a review article in implementation science. That's very great. That's a great suggestion.
I mean, there is still the risk of how the systematic review portion of that meta-analysis was done, and that's still manually sorted, where you can actually compare the output of the large language model against that manual triage of the literature. But there is another question online from Andrew.
Yeah, Andrew, go ahead.
Another Andrew.
Sorry, I was struggling to unmute myself. Yeah, no, this was fascinating. I don't know, because I was a little bit late, if you had listened to Planet Money did something similar to this, and they did a 4 or 5 part podcast, I think, last summer, where they were using ChatGPT to analyze their past transcripts of their podcast. And they used something called, I think it was Llama Index, as a way to get around the token limitation that you mentioned, because that is like a struggle when you're trying to summarize a whole paper, for example.
Yeah. I don't know that particular method. I'll have to go look at it. For me, the idea that there are these more or less standard sections and they contain information was a very, very natural way of doing this. The problem of you're not being able to give the entire data set to the large language model is real and known, and I can't think of the name of this technique, but one of the approaches that's used when you have a large database of text, for example, if you're trying to use the large language model to answer questions about your own products, if you're a company, and you have say you have 500 product descriptions, okay? What is being done now is the documents are being selected by using some other method that correlates the prompt to those documents. And so what's done is this correlational method, which is like a similarity method, pulls the documents out, and then those documents are handed to ChatGPT to answer the specific question based on now that reduced set of information. So that's the way it's being handled right now. It has an acronym. It's just not in my mind right now. But yeah, but somehow you have to shorten things. I mean, I certainly cannot give it the database of 2,000 papers. Doesn't work.
Alex?
Yeah. No, for sure that is you glossed over it quite, in the talk, and in some ways, is it as cool or interesting as a large language model? No, but the fact that you're using PDF as your source of truth and then parsing out the sections is actually, I imagine, a painful process and fraught with other problems, because PDF is a layout format, not a semantic format.
That's absolutely right. And so I'll talk a little bit more about that since you asked me. Of course, I go out and find code that I start as an example. And I did find, I spent a lot of time figuring out PDF files, but I found code that will pull out the text section, but also will pull out tables, because it has this notion of a table object. And then it has a notion of an image. Okay, and so initially I was using the text and then also the information from the tables, and then I was using a text recognizer to see if there was text in the images. And I was organizing it as though it were basically two columns. So the order that things were given were down the right column, and I know the position, so I actually have to sort. I have to sort these objects based on where they are. And then the tables and the figures are sort of added on the end of that, and that becomes all the text on the page. So, so what I actually do is pull all the text out of the pages, and then I look at, for a section, the beginning page number and the end page number, put that text together, and then try to truncate it by using, if those of you who are technically oriented, by searching for the section title using regular expressions. And then I search for the next title using regular expressions, and I try to pull that section of text out that just corresponds to the section. Now, if I'm not able to do that, I expand it. So I err in the side of giving it too much text, or more text than just a section rather than less. But yeah, it's a mess, truthfully. It took a long time, and some problems I just, in some sense gave up on. So I am going to go back and eliminate pulling the text from the tables, unless I can figure out a way to only pull the text from the table, description, which are sometimes, really informative. But what's happening is if the table contains a lot of numbers, then this is getting translated into a huge number of tokens that is exceeding the token limit. But yeah, no, that was the problem. That's the problem. Some journals have not PDFs. They have HTML versions of the papers. And HTML is a much more structured format. You know, I'm going to go implement that at some point as well. But, you know, I was getting too scattered, so I had to make decisions, or I wasn't going to make any progress.
You reminded me of the world of quality improvement, quality control. And to what extent are we going to be changing the way we do audit and inspection? Do you think it's going to be a large language model that is going to be doing just that in the future?
Well, that's a great question. So right now, obviously these large language models are used in a chatbot format, right? And you know, I and others are using them to pull. Well, they're being used by places like Amazon to summarize reviews. I'm using it a little bit differently. I'm using it to pull data. And other people are doing that as well, although, you know, I think this context may be, you know, kind of unique. Certainly, you could use these models to monitor sentiment, for example. You know, if I had a lot of reviews coming in, I can think of that as a flow of data, very much like process data, and I can you know, assess the sentiment and produce a control chart, see if something's going wrong. Yeah.
You also reminded me of John C. Maxwell, who said, good leaders ask great questions. So maybe that's the future of prompt engineering and leadership and process improvement.
Yeah. Yeah. The prompt engineering is interesting. As I say, I think these prompts look different than most people think they do. They're much more complex.
Well, we're going to need to do another 1 hour session about what's going to be the next iteration and what's the future of this project. But this was very, very innovative, very
Can I share you one more thing here?
Sure, absolutely. Absolutely.
Very quickly. So when I ask ChatGPT to do something like pull the roles out, I get sometimes 1,500 roles. Okay, so I get such a long list of things that it's not useful to me, and I'm trying to figure out if I have an example where I can show you this. It's not in that file, and so what I have to do is consolidate the terms. Bear with me for 2 seconds here.
Sure.
I'm looking at add one. Okay. Innovation process. Okay, that's that. Healthcare roles. No, I'm not seeing it. Experimentation information. Okay, that's not it. It ought to be in this file. Bear with me for 2 more seconds here. I'm sorry about this delay, but I'd like to give you a visual of what. That's simple. Maybe it is in this one. Okay, let me search for the word fix. Not there. No, okay. I'll try one more time here, and then I'll give up if I don't find it. Well, okay. So here's what I did. So, you know, I ask it for the role of the people affected. And I get this list that's, say, several hundred long. And what I need to do is consolidate them. Oh, I know where it is. I know where it is. Sometimes it's hard for me to keep track of where everything is. Bear with me. So what I have here now is this is the research methods. So I got, this shows you all the research methods that ChatGPT pulled out of the file, hundreds of them. Okay, and so in order to make these graphs, I have to reduce the terms by merging the similar terms. Now, the first time I did this on one of the categories, it took me about 3 hours to do it. Okay, so then the next thing to do is to think about asking ChatGPT to merge the terms.
Right.
Okay, so what I did is for each term I asked ChatGPT to score the similarity with all of the other terms. This is a big, a big for loop, a big do loop, on a scale of 1 to 10. Okay, because it should know something about the language. And then I collapsed all terms where the similarity was 9 or 10.
Okay.
Okay, and that reduced it a lot. Okay, and then I did handwork on that. Okay, what I want to go back and so part of this is we've in a way been having a discussion about using ChatGPT on the output of ChatGPT. Okay,
Right.
and that's kind of what I've done here. What I'm going to try next is to say, I've got say 1,000 terms here that it's pulled out. The way I thought about doing it is to say, well, tell me how similar they are, and I'll just combine the ones that are similar. But I think now I may go back and say, give it a much more general problem that says, consolidate this list into 100 terms. Or 50 terms or 25 terms, whatever, and see what it does.
I thought you were going to go to the direction of creating a support vector machine model to try to cluster those.
Well, I probably should think of other ways to do it, but the reason why I wanted to search for this is to give you a visual of how, in some sense, detailed, granular, the output can be, and it's actually been hard for me to get it to compress it down to the small enough number of categories.
Right.
Okay.
This is fantastic. Okay. More work for us to do together, I guess.
Yeah, no, there's so much here. So I'm excited about it. It's keeping me out of trouble. So.
Imagine in the future you have a journal that is publishing on the side the impact factor real time and this type of analysis of what type of papers they published and what's the strength, what's the output in terms of new evidence-based practices and interventions and process maybe related metrics of scaling up or adoption of those interventions. So that'll be very nice. Well, thank you so much, George. This was great.
All right. Well, very good. Well, it's been fun, and I would love to hear from anybody who has ideas about what we should be looking at. That would be great, or other useful techniques that I don't seem to know about it. I mean, it's very difficult, to have broad enough knowledge these days. So.
Perfect. Well, we'll stay in touch and we'll work in teams here. Thank you.
Okay.
Thank you.
All right. Very good. Have a good afternoon.